Okay, let's give you guys some more practice. So here, find the limit of cos of x over x as x tends to 0. Okay, so press pause and have a go. Okay, so to do this here, if you ever get stuck, get a graph plotter and plot this this line here. By you seeing the graph, it might give you some inspiration. So when you get a graph plotter, it will look like this. Now, you want to find out the limit. You want to find out the limit as x approaches 0. So looking at this here, as x approaches 0 from the left hand side, it's going down here. As x approaches 0 from the right hand side, it's going up here. So you've got a hunch that is, well, you can see that the limit here doesn't exist. But then you should realize that when looking at this here, there's a theorem that states that if this here heads towards a definite limit and this here equals 0, then overall the limit does not exist. There's a theorem that states that. So if you look at this here, as x tends to 0, this thing here, cos of x here will look like this. You see cos of x here equals 1, and then at the bottom here, as x approaches 0 here, this will be 0. So whenever there's a theorem that states that whenever this here heads towards a definite limit other than 0, and this here is definitely 0, then overall the limit does not exist. So the answer to this here is that the limit does not exist. So keep an eye out on when you're doing limits. Keep an eye out on this being a definite limit and this being 0. Whenever you get a definite limit at the top and a 0 at the bottom, then there's a theorem that states that overall the limit here does not exist. Okay, so another question here, hang on. So yeah, if you get stuck, try to get a graph plotter, plot the graph, and then it might give you some ideas. Well, anyway, the next question here, find the limit of this as x tends to pi over 2. So pi over 2, so visualize it as a circle here. From here to here is pi over 2. So it's pi over 2 is like 90 degrees. Well, anyway, press pause and have a go. Okay, so if you get stuck, get a graph plotter and plot it. You see, as x approaches pi over 2, so pi over 2 is here. So this one here is going to head up here, and then from the right hand side, it's going to, well, you can see that here the limit doesn't exist. So looking at this here, you should realize that as x approaches pi over 2, sine of pi over 2, sine looks like this. Pi over 2 is 1 here. So this will be 1 plus 1. Let me think. Yeah, 1 plus 1 over, and then as when you look at the cosine, it will look something like this. Yeah. So this here will be 0. You see, just like in the previous exercise, this here is a definite limit, which is 2, and then this here is 0. So you've got a definite limit at the top, at the bottom is 0. So there's a theorem that states that whenever you have a limit at the top and this is 0, then you know that the limit does not exist. So it does not exist. So when you're doing limits, try to keep an eye out on this being a definite limit and this being 0. Whenever that happens, then the limit does not exist. Okay?